Now for this particular question, what we've got to do is prove sec squared x minus cosec squared x is identical to tan squared x minus cot squared x. And to do this, what I'm going to do is we'll just write down proof, and I'm going to start with the left hand side. Now you can either write LHS is identical to, or you could just copy out the left hand side. I generally prefer to copy out the left hand side rather than writing out LHS, but that's up to you. So we start with sec squared x minus cosec squared x, and what is it identical to? Well, we can't assume it's identical to this at the moment, so we have to work towards it. Now we should know an identity for sec squared x. Sec squared x is the same as 1 over cos squared x, but that doesn't look as if it's going to be useful. But also we should be familiar with this one. Let's just put it over here, okay? You should be familiar with the fact that 1 plus tan squared x is identical to sec squared x, okay? Basic identity, as I say, that you should already know. So in place of sec squared x, I could write 1 plus tan squared x. That looks like it's heading up towards this. So we'll put that in as 1 plus tan squared x. Now we've got cosec squared x, and there's a cot squared x over here. And that reminds me, we've got another identity that you should already know, and that is 1 plus cot squared x is identical to cosec squared x. Right? So instead of cosec squared x, I'm going to write 1 plus cot squared x. But I've got to be careful here because we've got two terms, okay, and we've got this minus, so we need minus and then a bracket, 1 plus cot squared x. And you should be able to start seeing this falling out now, because if we expand the bracket here, multiply out with the minus 1 here, you're going to get minus 1 minus cot squared x. And then clearly the 1's cancel, leaving you with tan squared x minus cot squared x, which is what we had to prove. Alright? So I hope it's given you some idea then how to go about that particular part of the question.